All right, it says an engineer is going to redesign an injection seat for an airplane. The seat was designed for pilots weighing between 120 and you in my way, and 171. And the new population of pilots have normally distributed weights. That right there tells you to draw your bell-shaped curve with a mean, so right down the middle of 128. So that's the population mean. And then a standard deviation, I'll just put over here to the side, of 34.8. All right, if a pilot is randomly selected, find the probability his weight is between 120 and 171. So I don't know exactly where this is, so I'm just going to draw a line and say, okay, 171 and 120. And what I'm looking at is this area between. So to find that, I have to standardize both of these values to z-scores so I can look up the probabilities in the table. So how you standardize your z is you take, and we'll call this the lower z, you take your x value minus the population mean and then divided by the standard deviation. So if I just very quickly throw that in a calculator and divide it by 34.8, I get negative 0.22988 and so many other numbers. First of all, it makes sense that it's negative because a standardized mean, the 128 becomes 0, so anything to the left would be negative. And the second thing is the z-table is rounded to 2 decimal places, so always round your z to 2 decimal places. All right, and then the upper z would be 171 minus 128 divided by 34.8. So I throw that in my calculator, 171, and I get 1.23, so 1.2356, and once again rounding it, 1.24. All right, so let's look up both of these probabilities. So once again, these are my standardized z values. So I standardize that to negative 0.23. I standardize that to 1.24. And now I'm going to look up their actual probabilities in the table. So at negative 0.23 on my table. And let's hide you for a second. So negative 0.23. So I'm looking down the negative, on the negative side, the z for negative 0.2. And then I want to look across or down from the 0.03. So negative 0.23, and I get 0.4090. So 0.4090. So going back here, I get 0.4090. So 0.4090. Now I'm going to look up 1.24. So back to my table. I need to go to the positive side to 1.2. There's 1.2, and then straight down from 4. And I get 0.8925. So back here, 0.89, 0.8925. So the 0.8925 is all of this area, and the 0.4090 is all of that area. Well, to get the area in the middle, I simply would just take and subtract these two areas. So I take 0.8925 minus 0.4090, and I get 0.4835. Now, the lab gives you kind of, I guess you could call it some wiggle room on this answer, because if you rounded differently, you may have gotten a little different of a different value, But what it does, another thing that you can do, which is kind of cool, is you can open up StatCrunch. Okay, so if you just go to the question help and open up StatCrunch, you can go, make this a little bit bigger, you can go here to Stat, Z-Stats, one sample with summary, okay? And you could actually put these values in. Now you're going to see on the sample size, I'm going to do, when you have a sample size, I'm going to do something different. So another thing they have in here is if you don't want to look things up in the table, I can go to calculators, I can go to normal, and notice there's a standard and there's a between. So I want to do the between. So what was it, 120 and 171? So they told me the mean, oops, the mean was 128. The standard deviation was 34.8. And I want to find the probability between 120 and 171. And I hit compute, and you can see that I get a little bit different of a value by using the exact value from the table. But like I said, the lab gives you some error, some wiggle room, but this is certainly a lot faster. Okay, definitely using StatCrunch. So again, that was under Stat, Calculators, and Normal. The other Z-Stat stuff we'll get to definitely later in the course, so I just wanted you to see that. All right, so then from here, let's say this changed a little bit, and it said if 35 different pilots are randomly selected. So it probably kind of sort of to you looks like the same problem, but it's not. You are still doing the, get this going, you are still doing this, the 128. You are still looking for the area between, but now we have a sampling distribution, and the only thing that changes in our formulas, so I have 120 minus 171, and we've just been dividing by the standard deviation, but now you have to add this piece, the square root of the sample size. Okay, and of course you do this for both Z lower and Z upper. And again, if you wanted to use, just use StatCrunch, get StatCrunch here, you could, you just have to be careful because what changes is your standard deviation. So pick up a calculator and type 34.5 divided by the square root of 35. And what you would expect to happen is your standard deviation gets smaller. And you type in as many, how much accuracy you want. And so I got this 5.822 number, and I hit compute. And now you can see that probability, I mean, you can kind of even see it, that probability is going to be a lot larger. So we like to take into effect when we have a sample size that we divide off our standard deviation, okay, to make our standard deviation smaller, because now we actually have some information.